Okay, now for this last portion of our topic for midterms, we have the velocity and acceleration of particle using vector value function. So we know that r, no, our r vector is a way to represent the position of our point in a curve. So we have a point here, you have a point here, you have a point here, and so on. So we can imagine the r vector is just a position vector. You can imagine the particle is translating, no, into this curve that is your r vector, your vector value function. Now, in physics, we know that the velocity is just the first derivative of the position vector. No? So therefore, if you find the derivative of your position vector, then you have the velocity. And then if you find the derivative again of your velocity, which is v prime of t, or in other words, the second derivative of your position function, then you have the acceleration. Now again, given your position vector, you can find the velocity vector and the acceleration vector. So therefore, if you know the position vector of your particle, you can predict its velocity and acceleration using the differentiation and actually integration vice versa. So let's have this problem. So we have a given position vector of an object moving in a plane. So find its velocity, speed, and acceleration when t is equal to 1. Okay, so again, you have this position vector. Therefore, your velocity vector is just the first derivative of your position vector. And then your acceleration vector will be just the second derivative or the first derivative of your velocity vector or the second derivative of your position vector. Okay, so for the first derivative or the vector, sorry, the velocity, so the first derivative of this, we have 3t squared. So we have 3t squared I hat plus 2t j hat. Okay, so that's your velocity function. Let's evaluate the actual velocity later. And then let's solve also for the acceleration vector. So the acceleration vector is again the derivative of your velocity vector. So we have 6t squared, sorry, 6t only, and then plus 2j hat. Now to find the velocity, or sorry, for the speed, for the speed, what is the speed? So the speed is just the magnitude, right? Magnitude of your magnitude, magnitude of velocity. So what does that mean? If you have a velocity vector, let's say this is your Vx, this is your Vy, then your speed here is your V, your hypotenuse, no? So therefore, if this is your velocity vector, then your speed, so yeah, I will just write here literally speed, is equal to the length of your velocity vector, which is the square root of the sum of the squares of its components. So we have square of 3t squared, and then the square of 2t. So this will be equal to the square root of, so 3 times 3, we have 9, and then t to the 4th, plus 2 times 2, we have 4, and then t squared. Okay, so that's it. That is your speed, which is also the length of your velocity vector. Now, to find its velocity, speed, and acceleration at t is equal to 1, so we can find the velocity when t is equal to 1. So just substitute the value of 1 here. So we have 3 times 1 squared I hat plus 2 and then 1 j hat. So this will be equal to 3i plus 2j. So that's it, your velocity at t is equal to 0. For the speed, so for the speed, we have the length only, which is equal to this. So the square root of 9 times 1 to the 4th plus 4 times 1 to the square. This is equal to, so 9 plus 4, square root of 13. Now for your acceleration vector, so sorry, there should be 1. So substitute the 1 here. So we have 6. So 6 times 1 and then plus 2j. So this will be equal to 6 I hat plus 2j. Yeah. Okay, that's it. It is that simple, really. Okay, next. So last problem. A moving particle starts an initial position r of 0, 1, 0, 0 with initial velocity I negative j and k. Its acceleration a of t for t I plus 60j plus k finds its velocity and position at time t. So now we have a given acceleration vector, and then we want to solve for its velocity and position functions, no? So we have a given acceleration. We want to solve for the velocity and the position. Now, if your acceleration vector is the second or sorry, the first derivative of your velocity vector, then therefore finding its integral, no, from what? No, from 0 to t, right? From 0 to t, okay? Is that right? From 0 to t. Which will integrate this at 0 to t. Not exactly. Not really exactly. Sige. This is an indefinite integral pala, no? So we can cancel out this derivative, no? So therefore, the integral of this a vector is equal to the velocity vector. So therefore, integrating this, yan. So what is the integral of 4t? So we have 4t squared over 2. So the polynomial or the power rule. And then we have plus 60 squared, right, over 2j. And then this is just 1. So the integral of 1 is actually t. Okay? So this is your definite integral. We do not have a limit, so we have to add the arbitrary constant c. So this is actually a vector, no? But I won't write the vector anymore at this point. Should I? I think I should, no? So I'll just write here that c is a constant vector. A constant still. So now, what do we have here? So how do we now solve for the velocity function? So we're trying to find the velocity function, no? Velocity function. So basically your v of t. This is not yet the answer since we have still a constant. We have a given initial condition though. So we can utilize this one. So the v of 0 is equal to I, negative j, and k. So this basically means when t is equal to 0, you have this as your solution. Therefore, what we can do here, guys, is we can substitute this. So we know that this is your v of t. So if we substitute 0 here, then this will be, or sorry, I did not simplify this, no? So 2t squared plus 3t squared plus t a. Sorry, I did not simplify. Okay. So this will be now 0 I plus 0 j. So 0 everything, no? Since if you substitute 0 here, this will be 0, no? So plus 0k and then plus the c vector. So therefore, you can see here that the c vector, you can cancel this all as 0. So the c vector now is equal to I minus j plus k. So what can we do here? So what can we do here is to substitute this back. So we will now substitute this back to our original problem. So your vector valued function of your your velocity is equal to 2t squared I plus 3t squared j plus t k and then plus. So the c here is I minus j plus k. So this basically is your C vector. So you can now add no these two vectors in their respective components. So this will be, so what does this mean? This is just one, ano? So this will be 2t squared plus 1, and then we have I hat, and then plus 3t squared minus 1, and then j hat, and then we have t squared, sorry, not t squared, but t plus k, or plus 1, and then k hat. So this is your vector function for your velocity. Now for your possession, so for your possession, we know that the velocity is equal to the first derivative of your position vector. Therefore, if we integrate this again, we can cancel this out, no? So your possession vector r of t is equal to the integral of b prime of t. So we want to now integrate this again. So we have 4t, so 2 times t cubed over 3, right? So this will be 2t cubed over 3 plus t. So the integral of 1 is t. And then, sorry, we have I hat plus we have 3t cubed over 3 minus t. Then j, sorry, it is not too spacious. No? So t squared over 2 plus t and then k. So simplify this first. So we have 2/3 t cubed, I guess. Should we simplify this? I will just simplify it here now just to save space. So this will be just t cubed. Okay, that's it. Now, this has an arbitrary constant again of c. So to solve for this c, we have this given initial position. We have 1, 0, 0. So basically, we can substitute 0. So we have r of 0 is equal to, so this is also the same as just I plus 0j plus 0k, right? So we can just put here I hat, and then equals to, substituting t is equal to 0 here. So for this, so t here, substitute the t here, we have, so this will all be 0, right? So we have 0, 0 I, 0, 0, 0, 0 here as well. When t is equal to 0, this will be 0. So plus, we have 0, j hat, yeah. And then also for this will become 0. So plus 0, k, and then plus c. So therefore, c vector is equal to I hat. So what's next? So therefore, we can go back and add the c vector to our position vector. So therefore, your r of t, right, forgot to write the vector here. So r vector of t. So since this is just I, now we can just add this to our I. So therefore, your r vector or your position vector is 2/3 t cubed plus t plus 1 I hat plus, we have t cubed minus t j hat plus t squared over 2 plus t k hat. So this will be your position vector. Okay, so that's it for this video. I hope you learned something here, and see you guys in class. Bye bye.